Let's calculate some descriptive statistics. So you can see here in this set of 12 numbers, they're already in order least to greatest. So first we want to find the mode. Remember, the mode appears most often. So you can see that the number 12 appears 4 times. 11 is there twice, 13 is twice, and these are all ones, which means the mode is 12. Let's find the median. Well, the median is in the middle. So if we work our way to the middle, crossing off a low and a high each time, we have 2 numbers in the middle. So we want to take the average because the median will be right in the middle. So 12 plus 13 is 25. Divide that by 2, and the median is 12.5. The mean is found by adding all 12 of these numbers together. So if we add them all and then divide by 12, we'll get our mean. So if you add all of these numbers together, you should get 241, unless I made a mistake. And when I divide by 12, I end up with 20.1. So the average age is 20.1, which is kind of weird because 9 of the 12 are younger than 20. Okay, letter D. If you wanted to sell merchandise to people at this show, what age should you target? I don't know. This is definitely an opinion question, but I would target around 20 because you and I both know that these people up here, if they're at a show where all of these, maybe they want to feel a little bit younger, or maybe they're parents of these people, who knows. But, you know, they want to feel a bit younger. And every 11, 12, 13-year-old, 14-year-old, they want to feel like they're 20. So, you know, if you target the 12-year-olds, you're going to alienate this group completely. Whereas if you target maybe upper teens, early 20s, you can hit a little bit of both as long as you keep it, you know, pretty nice. That is totally and completely an opinion. So this data is an example of being skewed right. What that means is the majority of the data they're young people, right? If we're talking about like this is 0 and this is 100. So a lot of them are young, but we had a couple of those old people. So if you would graph this, it would kind of go like this, meaning it tails to the right. We call that being skewed right. You will also notice that in this case, the mean is greater than the median because the mean was 20.1 and the median was 12.5. So you can see that this inequality sign moves to the right and this moves to the right. Same kind of idea. Okay, so in this one, we have 15 cars and we want to find the mode and the mean and the median. But notice they are not in ascending order, so least to greatest. So the first thing we want to do is put them in order, least to greatest. Okay, I'd like to put one number underneath each number. That way I make sure I don't miss any. As long as they're all lined up, then I know I'm on pace. So first we want to find the mode. What appears most often? Well, you'll see that 3 is there 4 times, 4 is there 4 times, 5 is just 3, so that doesn't work. So our mode is 3 and 4. We call this being bimodal because there are 2 numbers that are both there the same number of times. The mean, again, we add them all up. So when I'm finding the mean, if I add everything together, I get 59. I divide it by 15 numbers, and I get a mean of 3.9. The median is the middle number when they're in order least to greatest. So if I work my way to the middle, there are 7 numbers on this side, there are 7 numbers on this side. So that 4 all by itself is the median. Now we would say this data is pretty much symmetrical because, right, again, if this is 1 and this is 7, we have 3, 4, and 5 that are all kind of the same, and then it goes down to 1 and 2, it goes down to 6 and 7. So it's pretty much symmetrical. You'll also notice that the mean is approximately the same as the median because the mean was 3.9 and the median was 4. So when the mean and the median are kind of the same, pretty close to the same, you're going to have somewhat symmetrical data. Being absolutely symmetrical is not very likely in the real world. Okay, so now let's go to Professor Ivy. So we have 8 exam scores. So we want to find the mean. So we add all of these together. When we add all 8 numbers together, we get 447, and we divide by 8 students. And that gives us an average of 55.9. Now, that's over here, right? 55.9. The median, if we work our way to the middle, we have 2 numbers in the middle, so when I add those together, I get 147 divided by 2. The median is 73.5, right there. So which one of these, the mean or the median, is the better representation? I think the better representation is the median because these two zeros drag that mean down so much, right? If you did not count those, if you just took the 447 and divided by the 6 people who actually took the exam, the average is 74.5. So you can see that's way more representative of those who actually took the test. So 73.5 is pretty close. So the median actually represents this data better than the mean, because these two zeros, we call them outliers, really bring down the value. And that kind of leads us into part C. The zeros affect the mean by decreasing it dramatically. And really with the median, it really does not affect the median, because the median is the middle number. The zeros are on the outside all by themselves. And we would say this data is skewed left, because most of our, if we're talking 0 to 100, we have 2 scores over here, and then the rest of them are over here. So it kind of goes left. And you'll notice that our mean is less than our median, because our mean is 55.9, our median is 73.9. So you can see how our inequality symbol points left, and this is skewed left, right? That's the way the tail goes in our graphic. Hey, that's the end of the video.